I'm a super senior software enterprise architect from Universal Mind. Brian O'Connor gave me that title for some reason, so I don't know what that means. So a little bit about me. As I said, I'm a software consultant, enterprise software consultant. I'm the author or the creator of the SWIS framework. There's actually quite a few people involved. Co-author of the Cold Spring framework. If any of you guys do Cold Fusion development, I was involved in that for quite a long time. I love open source, like avid contributor, and a long-time CF, Java, ActionScript. Started doing internet-based work in about '95 and been basically riding that wave. So today we're going to talk about SWIS. So I think briefly Andy started talking to people and asked how many people use frameworks or whatnot. So I want to do a quick overview of basically what SWIS is, what it isn't. Why did I put these things in here? So basically, just quickly in a nutshell, what is SWIS? SWIS is an inversion of control container for ActionScript development. Do any of you know what inversion of control means? Couple people? You can yell, say no, yes.
Bring IOC.
Good, okay. So I'm going to talk about IOC real quick, briefly first, and then break into some other things. So SWIS also provides an MVC paradigm for development. You'll talk a little bit about that as we show some sample apps, and I'll show you how and why. And most importantly, SWIS makes common tasks simple. That's the basic concept of SWIS. It's not really a prescriptive architectural framework for how you should write your applications. It's more of an internal framework for how your applications create themselves and are structured. Really importantly, SWIS is easily extendable. And after I show briefly the overview of SWIS, I'm going to talk about some of the new stuff in SWIS 1.0 and how extensible the framework is. So what SWIS is not? SWIS is actually, inversion of control is a JE pattern, and you might think of it as a little bit excessive, but SWIS in general is not a framework that forces patterns on you. This is quite different from some of the version 1 frameworks that we all started with that start with a C and end with the ORM. SWIS does not require you to write a lot of boilerplate code. It tries to make things more simple, so things like event handling are not done with lots of classes that are repetitive to write. We have a real simple way to do that. SWIS is inversion of control, which means it needs to know about your objects, but it doesn't do it with verbose XML configuration that tell all your objects how they need each other. And importantly, SWIS is not overly prescriptive. So I just quickly want to introduce you to who is involved in SWIS, because it's not just myself. It's actually got some really great people from really great companies. So first of all, there's Chris. That's Chris Scott is me. I work at Universal Mind. We have Sankey Rhodes, who's ex-Adobe, and he's now at Salesforce.com. Ben Klinkenbeard, that's actually his name. Some people think I made that up and just to add contributors to the slide, but he's a real person. Darren Shaw, super bright guy from Universal Mind, barely ever contributes code, but he's a really cool guy. Ryan Campbell is a genius, and I'm going to show you some stuff that he wrote at the end that is like unbelievably mind-blowing. David Tucker, Jen Yanarella. You might see a pattern at the contributors, but we use this tool at Universal Mind, so we contribute to it. Brian Kotek from Booz Allen, and our community evangelist lead, whatever person who yells at us for not releasing things, is Adam Lehman. All right, so let's talk about inversion of control, because at the core of SWIS is an inversion of control framework. So a couple people sort of know, a couple people don't, but I'm going to basically go over it, and I want to do a little example of what inversion of control means. And earlier I passed out some little white cards, and I made this really annoying by putting them all over the place. So if you have a little white piece of paper, please open it. And what you guys are is your application components. And their paper tells you what you are and what you need to operate. So I would like you all to stand up and find the people you need and make an application. And you might want to yell, because I don't know how you're going to find each other, but it's your job because you're not using inversion of control.
I'm the only one. I'm a user controller. I collaborate with user service and user presentation model.
Well, I need you, because I'm a user presentation model.
All right, so keep going, find each other. So what we're seeing here is each of these people are application components, and they're starting up, but they know what they are, they know what they're supposed to do, but they're also doing a lot of annoying work walking around our theater here, trying to find the things they need to make an application. And that's taking a long time.
Where's my user
Right.
service?
A user what?
Oh, no, not the guys with the stickers on them. You sit down. Jeez, you're not even part of this application. All right, so you can sit. That one went. Half of our application went to the bathroom. That's not very helpful. All right, so you guys can sit back down because that doesn't work at all. So,
User service
oh, they want to keep going. All right, very good. Thank you very much. Everyone, give them a hand. So, basically, what we see here is each of these person was a specific type of component we use in our application, like our controller, our user service, our presentation model. However, when our application starts, they were doing things that have nothing to do with being a user controller, a model, a service. They were doing wiring of the application. So what inversion of control tries to do is take all of that responsibility away from you as a programmer and do it in a different way. Now, in Swizz, we do this by allowing our application components to tell something, and in this case, it's a core factory that Swizz is, what they might need to work. And they communicate to the factory, and then the factory does the work for you. So I'm going to show you another type of application with one component that evidently likes to be reused. And this time we're going to do it the Swizz way. So over here I've got a good friend of mine, Andy Trice, which I'd like everyone to welcome because he's just made an important career decision move that we're all very proud of. This is my friend Andy Trice, and he's going to come up. He's an application component. Right here on his little sleeve here, there's a little thing that tells me what he is. So he is a user view, and he needs a controller and a presentation model. Now, from him getting onto the stage here, because that's how Flex works, me as Swizz, I've noticed that he came on the stage, and I've learned a little bit about him. And now since I'm smart and I'm a component for him, I can go find things he needs. So he needs this controller and this presentation model. So why don't you guys come on up, and let's see what they need. So I cannot read in the dark. So he's a controller. The controller needs a service, so let me get the service. So you're the presentation model, he needs you too, and he needs the service. So let's put you guys together, and we'll give you guys to the view. All right, so now we have a nice application, and these guys just needed to do their work, but they didn't need to do the job of wiring themselves up. So thanks a lot, guys. You can sit back down. Right, so basically, what we're doing here is instead of these components taking all this role of trying to figure out what they need to get their job done, they're relinquishing that to some other means, and they're releasing the control of it to someone to do from the outside. This is where the term inversion of control means, because instead of you as a developer from inside your application components trying to figure out what you need, you're inverting it out to some exterior factory or function that will then figure it out for you. The nice thing about this is as a developer using an inversion of control container, I can be sure that when I go to use a component that has collaborators, things that it needs to run, I don't have to worry about how they get wired together. I can trust that these things are ready to go. So just briefly recap, you write applications, they're going to require a lot of components, right? They're going to require bits and pieces to run. And now those components require others. We call those things they need collaborators, right? And if I wire them myself, I'm writing a lot of extra code that's nothing to do with functionality. I could use lengthy XML declarations. If you've ever worked with Spring 1.0 or Cold Spring, you know how this configuration file goes where you describe each component and what the component needs, and you put these little nested elements in that. I could do that, but that's a lot of extra code. Swizz uses metadata. So this is akin to the way the newer Spring works with annotations. In Flex, when you write the bindable tag, that's a metadata tag that's not really code specific. It's not part of your functional code, but it's a declarative that we can pick up from other tools. So we use that metadata to express our dependencies, just like the hello, my name is signs showed me what these guys coming on stage needs. And the cool thing is that the IOC container goes out and figures out everything we need pretty much by itself. So what else is there? So Swizz, one core part of Swizz is obviously the inversion of control. On top of that, we give you simple tools to do simple tasks. One of the most pretty much good 50% of the Cairngorm framework was how to dispatch events, wire up commands, put a fake front controller in front of that, and then eventually make a remote service call and do something with the data, and it required 5 classes. At the end of the day, all we were trying to do is get data from a remote service and have some sort of management of that process. Well, Swizz does this with one function. One we deal with with normal event handling, standard Flex events. We do it through metadata, and we provide automatic wiring of event listeners for you, and we do it really simply. Swiss has the craziest simple module support you could think of, and I'll show you that a little bit later in the demo. And some of the new features, we have event and command chaining, so you can have little sub-processes that you can trigger off with one simple call that can branch off into a whole bunch of other events, and then at the end do something else. I'll show you that. And then we have extensibility, and this is probably the coolest thing that Swiss 1.0 brings to the table is the extensibility. So let's take a little step out of this, and we're going to take a look at a real application. So, oops, forgot to set my font. Sorry about that. All right, is that big enough for you guys?
Yep.
All right, so this is a little contact manager application in this. A bunch of us went out to MAX this year, and Christoph Konrads sent out this application that comes with LCDS, very slightly skinned differently, and wrote a really bad implementation and asked us to do our own versions of it. And then all the framework authors got together and had a really long session where we walked through the code to this. So I want to show you this basic application. So it's a little contact manager. You can search for people. If you click on them, it'll open up a little contact editor. You can take a picture. You can have a runtime error from something or other that I have no idea what I did. Oh, I think I did something with the picture editor thing, but let's pretend that didn't happen. I can create a new contact and save it. So basically, I want to walk through how this application is put together. So this is pretty simple. So the first thing I want to show you is the components that we use in this application and how we define it. So the core thing is Swiss has the ability to obviously find out about my components, but somehow or another I need to tell Swiss what my application is using. So I do this through a component called a bean provider. And this is a Swiss class that you extend in MXML, and you just basically put whatever you need to use, like in this case I need to use a remote object here. Don't worry about the service helper, but I have a couple of controllers that my application uses, and I've got some presentation models, and then I have a special presentation model that's I'm using a prototype. That's important because that enables Swiss to give a new version anytime you ask for that. And I'll show you where that view is being used. So by providing all these objects to Swiss can then go look at them. And when it loads up, it's going to make, internally, it's going to do a whole lot of work for you on the classes themselves. So it can figure out a lot of things for you. It does it really, really fast, caches everything so you don't have to worry about performance. And then from then on, whenever your application needs something, it knows how to wire all these things up. So if we look at, so how do we start this up? So in order to have an application that uses Swiss, all I do is I create this bean provider. I put my application components in it. And then in my main application, all I need to do is I need to drop a Swiss tag on my application. I've broken this out into a separate file because it's just kind of easier for me. But basically, this is your standard Swiss declaration. You can you extend Swiss, or you can do this inline. I have a bunch of configuration parameters if you want to overwrite some things. You don't have to really put anything there. But most importantly, I provide my bean providers in an array, and I can break up my components any way I want. So if I want to put my services in one function, in one file, controllers in another, that's how I do it, and it's no big deal. So when this application starts, it's going to see this Swiss tag. It's going to start up. It's going to load that bean providers, and that's where all my components are going to come from. And they'll now be available for the rest of my application. So that's all you need to do to start Swiss. From there on out, you're not going to really use any other MXML tags that are Swiss specific. There's very little in your code that you're probably going to need to do. Probably don't need to really extend any classes or anything. And you basically, through one tag, get all the things Swiss can do without having to litter your code all over the place with Swiss stuff. So and I'll show you how the views in a second. So before we jump into the components themselves, I want to show you something because this is kind of really important to the paradigms of Swiz. Is I want to show you my main views. So if I go into this application, you'll notice that this is my my actual main view that renders out the tab navigator that we saw and a little toolbar. If I click on my toolbar, that's what that looks like. I need this class open. This is my toolbar that was across the top, and this is my contact list along the side, and then I had a little super tab navigator on the view that was the main forms that we saw. Now, there's something I want you to notice about these views. Does anyone notice anything specific that's maybe a little bit different from what they normally see in views that you write in Flex apps? There's no script. I have no script blocks in any of my views. So I've taken all my ActionScript programming and they're not here. This is really important because Swiz provides a really good way to separate our application logic away from our view logic. This is part of MVC, right? So this is all I have view-wise, but there's no scripts there. Instead, I've got a presentation model, right, which is a really good way to separate out functionality. So instead of having a whole bunch of actions that a view may need to define, I've got properties that the view can display, and I've got a little bit of behavior behind that in a file, and then later I've got behavior in another file on how to do work, but it's all separated out, and that's really the MVC paradigm. So as you noticed, I should have replaced that. So you can use two different codes for injection. I left the AutoWire here, but you're going to see the more standard inject tag in a second. But in my views, I've defined that I need to use a couple components, and that's where this AutoWire tag comes in. So when my views come on stage, Swiz is going to say, hey, this one needs a presentation model. And this one over here needs a contact view presentation model. And the toolbar doesn't need anything. So if I go over into my app beans, my bean provider, you'll notice here's my presentation models defined right here. And here's the other one for the contact form. So all I need to do is declaratively through metadata tags say, I need this when I start, and Swiz takes care of the rest. I don't need to do anything else. I don't have to worry about if I need something to be a singleton or if I need something to be a prototype, meaning it's used in like multiple, like a tab, and I want lots of versions of it. I don't need to worry about that. It's all defined right here. So that's the most simple thing, is the basic auto wiring. So let me go into my controller for a second. You'll see the same thing. Here you see my use of two tags that mean the same thing. I've auto-wired in my contact service here. So Swiz, again, it sees this controller and it says, hey, I need that remote object. So it's going to inject that in for me. I also need that service helper that you might have seen. I'll show you that in a second. It's going to provide that for me. And the same thing with the dispatcher. So when Swiz starts and you put that Swiz tag on your application, it automatically grabs wherever it lies, which you should put on your main application, and says, hey, this is the core dispatcher that I'm going to use for all my event handling. That's really important because it provides this global bus for you to pass messages across. And you don't have to worry about doing things like cairngorm.getDispatcher, dispatch event. You can just use standard bubbling, but we've reworked it so it does all the dispatching or event handling in the capture phase, which is the first thing that any dispatching would do anyway to go from top down. It does it very early and captures all your events early for you and then applies them to whatever event handlers you have. So it's really simple. So that's our controller. So let me take you through the next bit of things. So we see how auto wiring works, right? You put your beans in the bean provider, you use the inject tag, and now you have your objects. Couldn't get any simpler than that. So the next thing I want to talk about is event handling. So this is my my toolbar, which that wasn't the one I was looking at. If we look up at the top, this is the toolbar here, and when I perform a search, I want to take the characters that I typed in and I want to throw an event out. And somehow or another, my application is dealing with this search. And this is a little bit of a round trip that I want to show you because it takes all the components into play. So this is my button in my toolbar, and when I push it, I'm going to dispatch a contact event. I set its type to edit. Oh, wait a second. Wrong thing, function. This is my search box, sorry. has a text input on change. I'm using normal dispatching to dispatch a bubbling search event of type search, and I'm putting the text from the search box. So this goes out into the stratosphere, basically, and somewhere along the line, Swiz is going to apply this to something else. So obviously, we want to know how that's happening. So this is done with the second major piece of Swiz, which is the dynamic mediation function. So here, I've got some functions defined in my controller that are event handlers. Now, I don't have to declare them as event handlers. I don't have to do any of the wiring and loading and unloading or removing and adding and removing the event handlers. I just define them through a metadata tag. And this is Swiz's mediate. So here's the search mediator right here. And so I've taken the event type of the search property on the search event. We do this, I could use the string. Oh, great, someone's calling me. Let's quit Skype so we don't get that again. That's my product manager, so she's probably wondering what I'm doing right now, even though she knows I'm here. So I'm dispatching out this search event. I could have put the type of the search, the string type of the event type in this mediate property, but instead I'm using the class name and a property on that class. And this is a little bit of a trick. What this does is, this is the property it's looking at, and this is the string that's the type. But by defining that event as a class with a property, and also in my root Swiz, I've defined an event packages on my Swiz config. Swiz automatically knows to go try to evaluate that as a real class and a real property when it goes to create this event listener. The reason we do that is because there's no way to provide strong typing in metadata. So if you misspelled that, your app would just break, right? Because the event handler would never get called because you mistyped the event type. But by doing it this way, I can cause Swiz to throw a runtime error as soon as my app loads, and it'll tell me, hey, this type doesn't exist. So it's a way to provide like runtime strong typing of magic strings, right? Because anything you write in a metadata like this is basically a string that you could type in correctly. So basically, when Swiz starts up, it's going to look for this event type. It's going to create an event handler. And the event handler is going to internally call this function that I've assigned. But you notice, in this case, I didn't want to pass the event in. I just want this one property, which is the string, the text being searched for. And we assign a property to an argument with the properties property of the metadata. So in this case, my event over here has a search string property, and I've defined, hey, pass that search string as the first argument. And this will be a comma delimited list of arguments. So the reason why we have to write this out in property names is my arguments could be 2 strings, and I could randomly look for strings in the event, but I probably wouldn't get the right one. So this way we're saying, hey, I want the first, the search string here. It could be first name, last name. Define how to pass it in. If I don't use that properties at all, such as in this refresh event, then nothing would get passed in. However, if I put an event here, just like that, Swiz is smart enough to know, hey, this guy actually wants the whole event passed into the function like a standard event listener, and we should handle it. He wants to handle it itself. So Swiz is smart enough to figure that one out. So at the end of the day, I dispatch the event, and Swiz has automatically created this mediator for me, and it goes right into the function. So you can see this is really reduced a whole lot of code, right? I don't have to make any event handlers. I don't have to worry about the wiring. I don't have to worry about the life cycle. And what's really important is that life cycle part. Swiz is handling adding and removing things when your components come around so that you don't have to really worry about that at all. So that's obviously helpful for memory issues. So we've talked about that. So the last thing I want to show you is how I get data. So this is the third of the major basic functions of Swiz. So Swiz introduced something called a service request utility. We used to have this in the abstract controller as a method in the controller that you could, if you want, you can extend abstract controller and get the same function, which is called execute service call. But if you want to do composition, you can just throw one of those in your beans and have it injected in. That way you don't have any special, that way your controller doesn't extend a special Swiz class. So it's up to you what you want to do. But at the end of the day, what we're doing here is in this, like, say, save context, for instance, when I mediate my event and I pass in the contact to save, it gets passed into this function. And now I'm calling a method on my remote object. When you call a method on a remote object, it returns an async token. And the way Flex normally, which you all write Flex, so you know how this works. Normally, to deal with async tokens, you write an iResponder implementation. Well, in this case, Swizz does it for you. And you just pass in a result handler, optionally a fault handler. You can see I only used a result handler on this service method above, but below I've used the service and a local fault handler. And so it takes the async token, behind the scenes creates an iResponder for you, so you don't have to write it, and then it assigns the correct function. So this way, I've got not only all my properties I'm dealing with, but I've got all my event listeners and then all my result handlers for service calls kind of all in the same class. What I provided here is a nice little unit of work that's all about my contacts, right? So this controller is just about how all the things I can do for a contact. And then in my result handler, I do my work. So one last little bit that you can do with the dynamic responders is you might need state over a service call. So I have a tab navigator on this app that we saw before, and when I press the save button, it takes that contact I've created and throws it at the server. So that calls the save method, but in my result handler, I want the original contact that I saved. So this is one of the main reasons for using the command pattern, because commands kind of are locked to the life cycle of the async token. But in this case, I just take the original object and I pass a fourth parameter, which is an array of arguments that you would like appended to your result handler. So here's my save result. I've received my result event, and then I've also received the original contact, right? So now I have that state management, but I don't have to write a whole bunch of fancy pants classes. I just call one little method, and it all gets handled for me. So hopefully you're kind of starting to see the code reduction here. So we don't have to write all those classes. We just rely on a couple of really simple things, and Swizz handles it for you. All right, so that's your most basic Swizz application. Before we move on, so any questions about what I just showed? Because I know I'm trying to go a little quick because I have a lot of content to show. But anything on the basic Swizz? So we've covered the inversion of control, how we provide objects, how we inject objects, how we deal with events. All makes perfect sense to everyone. You guys are ready to use Swizz today. Excellent. This is great. You guys are really smart. Good class. So now I want to move on to Swizz 1.0, which is basically code complete. The release candidate is ready-ish. Got maybe like one or two tiny tweaks. Adam's looking at me like I'm crazy. But we're trying to write documentation because, open source needs good documentation, and most of it doesn't have it. But we really want a good release that's well documented, so we're working really hard on our wiki. However, within a week, hopefully, easily, we should have a RC1. And if you want to go download the latest from GitHub, it's pretty much RC1. But don't tell anyone I told you that. All right, so what's new in Swizz 1.0? We used to have something called command chains. I don't think anyone really understood it or used it or had any idea what I was talking about, but it was cool. Ben Klinkenbeard had no idea what the heck I had done, but I explained it to him, and he wrote a much better implementation of it that is more abstract, and it allows for basic event chaining at a higher level. So you can kind of have more control over doing whatever you want. Swizz 1.0 will have very simple modular integration. I'm going to show you that very quickly. And then the coolest thing is the custom processors. So the main way you extend Swizz is by writing custom processors. And the cool thing about that is you can very easily look at a couple simple processors out there, and that's pretty much exactly how Swizz works. It's the same way that you would extend Swizz, which is pretty cool. So it kind of eats its own dog food, I guess. Oops, I don't know why I'm showing this like this, but whatever. All right, so let's see a couple of super cool 1.0 demos, and these are actually pretty ugly looking because I did them last night. All right, so I want to show you chains. All right, so I made this little project and open up my console. Yes. And you want to watch the console here because I put like slight delays, but because I'm setting properties on canvases using styles, everything is delayed until, because everything, if you were watching your session, you know that things go into the call later stack and everything gets processed at the end, but we won't worry about that. So I'm going to press this button and you'll notice in line with a slight delay, I receive these events to change colors and then attempted to change the colors at the time I received the event, but it didn't, and at the end I changed the colors. So it's pretty simple, but what you notice is I have one process that triggered 3. So how did I do that? So I basically I got a little Swiz app. It's got some beans in it. It's got a couple of controllers and a presentation model just like before. And my controllers have mediators in them. And they're basically mediating this color change event. I have 3 different event types. And all they do is they set a color on the application model, which the view is using. And then they count for a long time to make a little bit of a count. And then they set complete. So this is important because I have to tell the event that it's done so the chain goes on to the next one. So let me show you the actual chain. So in my main view, I've got a handler attached to my button that's calling this toChain method. And so I'm creating a new event chain because in this case I want to just dispatch events and I want to do them one after another. You can actually tell the chain to do everything all at once if you want, but the default is sequential. And I add members of a type of event. And what this chain will do is then dispatch these and wait for that event to say it's complete. So the important part there is my events extend a type of step, which is called an event chain step. There are also a few others that I have a slide about in a second. So basically when I've caught those mediators over in my controller, I say, hey, I'm done this event, and then it moves on to the next. And so, it goes farther than that. You can actually assign events to be dispatched when the chain is completed. You can assign fault handlers to it and all that kind of good stuff. But the basic functionality is you create a chain, you set its mode to be running in series or parallel, and then something potentially to happen at the end. You add a whole bunch of members and off you go. So it's a very simple way to do little sub-processes. And back to Keynote. So just a quick review. So basically, to make this event chain, I constructed an event chain. I supplied a dispatcher to it because I can apply events to happen in case of things like failure and success and end and stuff like that. The event chain extends something in Swiz called an abstract chain that you can also extend. And abstract chains can be made to have your own implementations of steps. So the important part is you add a member, which is in this case an event, which implements this iChain step, which can proceed. And then in this case in my mediators, I need to say I'm done with the event. That can happen at the end of a service call. So let's say if you looked at before where I had the execute service call, I could have called something on the server, passed the event back to the result handler, and only after I got data, I'd say, hey, I'm done. And then we would go on to the next. Swiz actually comes in with some other kinds of steps, like async chain step, which is kind of like a little mini responder. I can say, here's the call, here's the result handler, here's the fault handler, go do it. And at the end, it will move on to the next. I have a command chain step, which is pretty much almost the same thing. And then we have things like a function chain step where you can just add arbitrarily some function to call on some other object. So you can kind of think about, you can create kind of pretty complex things through this. Everyone understand chains? Any questions on the chaining? Is it too late in the day and you guys just don't want to ask questions, right? That's cool, I can understand that. Where's my clips? All right. So I want to move on, because the last thing is the coolest, I think, to a very, very, very simple example of how you do modules with Swiz. So I have a main application here, and it declares a Swiz instance that has a couple of beans in it. Or I've separated these out into controllers, just a normal controller and a presentation model. We don't have to really worry about what they are. The controller sets values on the PM and it just displays it. This is crazy simple application. I also have a module loader, and then I have another Swiz, which is a Swiz module. Oops. This is my user module. My user module also defines a Swiz instance. And this case, I've called it module Swiz, but it's just another Swiz with another definition with some more beans in it. When I run this, right, I've got a main application. It's reading some values off the PM. The main Swiz has started. And then when I load a module, it loads up the module, starts up some more objects. And this has two controllers in it. One of them creates, they're both using just UID utilities to create some IDs. But the important thing to notice is the application in the ID in the user module was inherited from the root application. So basically the way that did that is when I define a Swiz instance on a module, or even like in a tab navigator or lower down in my display stack or anything, the Swiz instance dispatches an event to go find parents. And as soon as it does, this is just like parenting in Cold Spring or Spring or any of those other ISC containers, the child can inherit beans from the parent. So my application bean controller was defined in the parent, but the child got to use it. And then when the child goes away, Swiz is smart enough to go, hey, I don't need any of this stuff. Let me get rid of all the mediators, injections, any bindings that it's made through it itself, and it'll unwire all that stuff, but you have the inheritance. So an important thing to know about modules is, so I talked before about how Swiz instances use a dispatcher from the parent application. Well, modules by default will inherit the dispatcher from that parent application so that I can communicate in and out of the application. So this is a brand new feature, and this is pretty interesting. So basically, when I define mediators, or if I try to inject a dispatcher into a module component, by default, it's going to use the global one. I can actually override that in my Swiz config by saying, hey, now I want to use a local dispatcher, and then everyone will have a private one. Or I can share it, and in my mediator, I can say, one mediator can use a global dispatcher, another mediator can use a local. And so basically, I get this way to communicate to the outside world or keep myself contained in the inside world. And I can do that with just two little properties. So it sounds a little more confusing than it is, but it basically gives you a private little space in your module if you want, and a global space outside. Alrighty. So back to my keynote. All right, so little review of what we just talked about with modules. Swiz jewels, I don't know what the hell I'm saying. It's very simple. It's no special tag. We just take a Swiz instance, we put it on a module, and we now have a new Swiz that's automatically wired up and is local to that module. Has its own dispatcher, which I can access through properties on Mediate, but it shares the parent, so I can, by default, dispatch back and forth real easily. One really important thing about modules is modules are loaded in, all the classes in a module are loaded into their own application domain, and that can be a real pain in the butt if you're trying to work with classes back and forth between your parent app and your child, or unload them or whatnot. You basically don't have to worry about it. Swiz has figured all this stuff out for you. It has utilities to find how to load the classes, how to create the type descriptors, do all the reflection, and it won't blow up. The important part is it just doesn't blow up, because usually when you work with modules, it blows up. But so we handled that, and you don't have to think about it, and that's cool. Swiz instance create a parent-child relationship, so a child can inherit or override beans from the parent. So if I have my own application controller with the same ID, I can just use that one instead. By default, we share the parent dispatcher. We can override that in Swiz config with Swiz config default dispatcher. And dispatcher and mediator can define a scope parameter to say, hey, I want to use the local or the global. Dispatcher has no other properties, so you can just write dispatcher parentheses local global. And local obviously uses the local dispatcher. Global uses the global. All right. So now we're going to get into what I think is probably the coolest thing that I've ever seen. You may not think so, but I'm a nerd, and I think it's damn cool. So we started adding extension points in Swizz, and actually these extension points are pretty much how we made Swizz. And so Swizz does some really complicated things when it starts up. You put all these classes in, and all these views come into its scope, and it starts seeing things. It does reflection on these classes. We cache everything, so we only call describe type one time. We make strongly typed classes for all the metadata tags. We cache all of them somewhere, and we access all that stuff. And we have really simple ways to access it, but there's a whole big structure underneath. And at the end of the day, we have these processors in Swizz that do things like look for metadata and then perform actions on them, like AutoWire and inject. That's a processor that looks for those two tags. When it sees it, it says, hey, I know what to do. The mediators are done with the processor. It says, when I see this tag, I'm going to pass it into this class, and I know what to do. We have a very simple interface for doing it. And the cool thing is you can use that interface yourself and make your own processors. And if you start looking out on the internet, some people have already caught on to this and made some really, really cool stuff. So I'm going to go back to that contact manager application. And what I want to do here is I want to start exposing stuff to the URL. So I can make a little REST style URL handler for the application. So if I go into my controller, I want to take this I'm only doing this on one function, but this is really easy to do. And I want to go on my search function over here, and I'm going to put this tag here. Right? So I'm going to put an extra metadata tag. Now this is not Swizz metadata. This is actually a custom metadata that my friend Ryan wrote. And he wrote a whole implementation behind this metadata about how to deal with URLs. But basically what this does, and I'm going to run this real quick. I'll probably mess something up, but let's give it a try. All right, so if I put a letter in to search for, if I go to the end of my URL, we now have this pattern appended to the URL, and that completely matches the pattern I've defined in my URL mapping. And this is REST style, so the parameter I put in is the same parameter that's defined on my function, or you don't actually need to use the mediator, but in this case I am. And this parameter on this function, so whenever this function gets called, the mediator, the processor he wrote gets notified of the use of it, and it then goes and says, hey, I need to do something with this function, right? And it applies this pattern to it, right? So now in my URL, right, as we saw a second ago, it exposes that URL out. And so what's really cool is all I needed to do is add a metadata tag and write nothing. That's pretty cool, right? I mean, it takes code to do that, but you don't have to do it. And it's bidirectional. So if I change the URL, it sends the search string back in there. All right? So I can't believe you guys don't think that's awesome. I didn't write anything. All I put is a metadata tag. There's no code here. That was all non-executable code, sort of. But in my app, non-executable. And I could sprinkle these out throughout my controller, and I could put that in my save event or my edit event, and then I could interact with the things that way. So this is going to get a little bit hairy, but I'm going to show you how you do this. So basically, if I open up Ryan's URL mapping processor he wrote, this is a processor Ryan wrote. Again, this is not Swizz. This is just another guy writing his own domain-specific language to do something cool. And you extend a base metadata processor, which is a Swizz class. It's the same processor we use, as I said before, to do a bunch of stuff internally. And basically, when I override when I create my constructor, I'm going to call super, and I'm going to tell it about the metadata I'm interested in. And this is an array, so I can pass in one, or I might make a processor to do a whole bunch of stuff. Sankey Rhodes actually made a Twitter processor that has a whole bunch of verbiage all about Twitter. You just put these metadata tags right on top of your presentation model or whatnot, and it binds to Twitter stuff like your timeline, friends, and all that, just right on an array collection, right? And he's doing all the hard work for you. So I define this. the metadata I'm interested in. And so now when Swizz starts, and well, the last bit, sorry, the last important part is that I've also told my Swizz instance to use this custom processor, right? So now it's part of the lifecycle of Swizz. So whenever I load an object and Swizz sees the URL mapping, it says, hey, I have a processor that wants this, so I should pass this whole structure I made underneath, which is my custom metadata object, onto the processor and say, hey, go do whatever you want to register this metadata. And at that time, Ryan is going to go in and make some event listeners and all that other kind of junk. What Swizz will call is two functions. Set up metadata tag when the object comes into play, like when Swizz loads, or if it's a prototype and the view using it loads or whatnot, and tear down when it tries to destroy the object. And it passes in the object that it saw, and our own sort of reflection version of that, but it's basically that controller in this case. And it also passes in a metadata tag implementation, which you can access the properties of the metadata tag. Now, the base properties are pretty minimal, and it provides a method called getArgs. But if you want to be really cool, like Ryan did, you can also pass in a custom metadata tag class, like Ryan's, that extend the Swizz metadata class and then make the properties easier to access. So he extended it and then added the getURL, getTitle, and then in the, this is internal to Swizz, but if you override the copyFrom function from a loosely typed metadata tag, you can go get the values this way with getArg and put them in your own little properties, and now you have a strongerly typed metadata tag, right? It's getting a little confusing, but it works perfectly. So at the end of the day, all I need to do is define the metadata I'm interested in and then override two functions, and I can do my own domain-specific language. So this is really, really cool for people who, if your organization is starting to invest in Swizz and you have your own language constructs that you want to work, if you were like really nuts and were like, oh, I've been totally sold on the command pattern and I have to use it, but I want to have some weird metadata-driven command, go write it yourself. And then make the processor register it, and you've got it. It's done. If you want to write a robot legs metadata processor, which go for it, man, do it. It'd be really easy. Just do it in a custom processor. So you can now start using it as a base engine to write your other tools. And I think for tool builders who want to build on top of Swizz, this is pretty damn cool. I mean, this is good stuff. I'm telling you, it'll be out any day now. It's completely code complete, almost right now.
And documented, right?
Well, the documentation is coming. My band is actually recording this weekend, so I am not writing documentation this weekend. But as we saw in that earlier slide, there's 10 people in Team Swizz, so we should be able to accomplish something.
Because I went through all the documentation on the...
Okay, so this is the other thing. There is a site that we're not releasing yet, that we're building all the new documentation on, which has a lot of content on it. But we're not releasing it because we're still editing it, massaging it, working on it. But there is a full documentation site that is not yet released to the public. So what is with the transitions? So to just wrap up again, talk about custom processors. Basically, you extend your base metadata processor. In your constructor, you're going to provide the strings that are the metadatas you are interested in. You're going to implement iMetadata processor. I don't know why I said that. The base metadata processor implements it, and you will override those two functions we showed you, which are set up metadata tag and tear down metadata tag. And when Swizz loads, it's going to pass this metadata tag object that it built around your metadata. I can probably say metadata 8 times in a sentence if I try. But you can Swizz will pass the metadata tag into the metadata method, but you can override with your own implementation of I give up. That's too many. But you can override it with your own implementation, and it will have more strongly typed. And it will also pass the object that it found the metadata on, so you can then complete the rest of your custom processing. And whatever your processor wants to do, it goes nuts and tears apart the application, breaks things, fixes things, whatever. It's up to you. All right, so that was a lot of content. That's pretty much a full 45 minutes, right? Or whatever. So I'm going to open it up to questions, which you already said no one has because it's clear as mud, so that's awesome. But here's some resources for you to get started, swizframework.org. There's going to be another resource here too, which we'll probably just switch the DNS. Let me just walk through the list, Mr. Adam. GitHub, what? Facebook. Fuck. Though that was last night. It was 12 o'clock at night when I got that. I had already done this slide. I go to bed at 12 o'clock at night. I get in bed and my wife goes, "Why did Swiz Framework want me to be a fan?" I'm like, "What are you talking about?" I had no idea. So it didn't make it on the slides. But we do have a Facebook page. Go become a fan because then we get a custom URL. And tell all your friends to be a fan because Swiz is awesome and you want to be a fan. And the Facebook page told you that we were speaking today. And no one else did, so that, except for Twitter. So that's pretty cool. So we've got our Twitter. You can follow Swiz Framework. If you love watching Swiz commits, you can follow Swiz updates, which I think we're actually also putting in Swiz Framework, so you can't avoid them. And our Google Groups site is at Swiz Framework. So any other questions? Wow, that must be the best. I'm very proud of myself. Everyone understands everything. Awesome. All right, well, thank you very much for coming. I really appreciate it.